I think the ideas brought forth by Bitcoin and Ethereum will evolve humankind much in the same manner as the web did. I will continue to work towards the vision of the global machine for computing consensus. I am a dreamer, and thanks to you, I am not the only one. I hope the consensus machine will join us and the world will be as one. The vision for ARC is that of a consensus machine, which means both private interactions between people and escalation to public information when it makes sense, both on and off-chain. And this brings me to the first AMA question. Could any of your projects support a decentralized content distribution system and workflow which is highly anonymous, capital efficient, and scalable? And the answer is yes. ARC is being built as a decentralized content distribution system. Not only that, but the target is that any private interaction can be provable. With ARC, each conversation is a blockchain of messages with a virtual environment compatible with the Ethereum virtual machine, with configurable functions, variables, and apps. Conversations are being implemented in a way that is scalable to groups, and we have already started to show content distribution by allowing ARC users to share marks with one another. And marks are Tailor and Markdown apps for ARC. Marks, by the way, are derived from a prototype of pipeline dApps that we had over a year ago, composed from pipeline graphs and Markdown, and they could be shared between people by QR code. Now, ARC is prepared to have multiple transport layers, and I have already tried with libp2p, Salty RTC, Socket.io, and I even managed to use Signal's chat protocol to send ARC messages through Signal by registering ARC as a second Signal device. And I have also been looking at that protocol, also end-to-end encrypted and supports local P2P networks, and IPFS-based encrypted content storage for chat backups. We plan to open the protocol so any transport can be used. And we were also thinking about P2P broadcasting protocols so you can use ARC to subscribe to both topics and people. But it is too early now to give you details at the moment. And there are many more ideas for ARC, and many more videos will come to explore them in detail. As Patreons, you will always know ahead of my larger audience about my plans, demos, and products. And I try to integrate bits of your vision in my products too. For example, the next version of ARC will have a new motto added in its motto set, inspired by one of you. And the motto is, community with nothing but your best selves. One of my current Patreon supporters asked me these questions about Tailor. How is the calldata for the Tailor interpreter contract created, and is Tailor truly an interpreted language? This AMA is a good time to go in depth about Tailor's bytecode representation, and this is a playground with the current in-work Tailor. Tailor has a human-readable representation similar to Lisp. This human-readable representation is parsed into a syntax tree. And you can see here a Tailor list with the str function and its arguments. This syntax tree can be serialized to bytecode. Now, how is this bytecode produced? Tailor is typed, and each Tailor type has a bytecode encoding. For example, the string type. It serializes into the type identifier and the value. And you can see this part is the type identifier and the rest is the value. In this case, the value is UTF-8 encoded. And this is the current encoding documentation, and let's look at the string type. All types are represented on 8 bytes, meaning 64 bits. For the string, the first 4 bits are the byte-like type ID. The next 2 bits tell us that this is a string. The next 26 bits are reserved for the string encoding, and the last 32 bits are for the length of the string. So this is what this type identifier contains. Each Taylor type has all the information needed to deserialize the bytecode by reading it from start to finish. And you can recompose the syntax tree and evaluate it again. So both the on-chain interpreter contract and the JavaScript implementation can understand the same bytecode. I was asked if Arc will also be available on mobile, and the answer is yes. I am working on a React Native app, but you can add Arc as an iPhone or iPad app right now. Just go to Safari, click on the Share button, add to home screen, and you get Arc as an app. To conclude, I take permission to quote you from Latin: per aspera ad ama.